Welcome back to the channel. It's a pleasure to have you here again. My name is Pendulum, as you know by now, and I'm your tutor on this channel, Pendumatics, where we study mathematics and break it down to make it simpler for you to understand. Alright, so welcome back. We're still looking at set theory, and we'll be looking at operations of sets today. Alright, so hopefully this video will not be long, and in this video you'll get to understand some of the very most important operations that we can do with sets. So if you're new to the channel, do well to subscribe and turn on that notifications button, ring that notifications bell so that you're notified each time we upload a new video. I typically upload 2 to 3 new mathematics video every week. All right, so welcome. What we'll be looking at is already on the board, so I will just take my time to explain it, and then we'll do an example together so that it is clearer for you to understand. Okay, and as we go into the video, remember to like the video as you watch, especially if you're finding it helpful. If it's clear and very understandable, do well to just drop a like on the video. Drop a comment as well. Okay, let me know what you think about the video, or if you have questions, and then do not forget to share the video. Very important. Copy the link, put it on your status, share to your friends, put it in your school or class groups, and help somebody that mathematics is threatening. All right, so let's begin. We have about 4 operations we'll be looking at. Number 1, we have subsets. Now, when you say something is a subset of another, what it means basically is that that thing is inside or within or a part of the other one. So if I say that Delta State is a subset of Nigeria, what I mean is that Delta State is within Nigeria. Delta State is part of Nigeria, or is a constituent of Nigeria. So the same applies to sets. So the subset of set A are all the other sets that can be formed from set A. The subset of a particular set A, in this case, are all the other sets that make up set A, that can be made out from set A, that can be formed from set A. You can say all the children of set A. Those are the subsets of set A. So for instance, if set A is 1, 2, 3, 4, if this is the elements in set A, then the subsets of A, all the sets you can make out of set A here are, you can make set X, which is 1, 2, 3. That can be a set you form out of set A. You can make set Y, which is 1, 3, 4. Another possible subset of A. You can also form another set from here, 2, 3, 4. Alright, now in this case we are forming set with 2 elements. If I want to make this bigger, set with 3 elements, 1, 2, 3, 1, 3, 4, 2, 3, 4. If I want to make it even bigger, that means if I want to have more subsets, I can go on to form sets with only 2 elements. So I can have 1, 2. I have another set that has elements 1, 3. I have another set that have elements 1, 4. I have another set that will have elements 2, 3. Another set will have elements 2, 4. Another set will have elements 3, 4. Alright, if I still want to expand it further, I can even have sets that will have just one element. 1, 2, 3, 4. Separate sets on their own. And then of course, an empty set is also a subset of this. So a set that has no elements is also a subset. And then the whole set is a subset of itself. So you should take note that every set has 2 automatic subsets, itself and an empty set. Every set has an automatic subset. Alright, it's just like every number is automatically a factor of itself. Every number can divide itself, right? So the same concept applies here. Every set can be formed out of itself. So every set is automatically a subset of itself. So one of the subsets of this set A, that is 1, 2, 3, 4, is also set P, which is 1, 2, 3, 4. Take note, this is automatic. And then also every set has an empty set in it. So if I remove all the elements of set A, I have an empty set as a subset, a possible subset. So what you need to understand is that a subset refers to all the sets that can be formed out of a particular set. All right, so there are so many in this case. You can form here. I only formed 3 element sets here. You can form the ones that have 2 elements, giving you more subsets. You can form the one that has 1 element each, giving you more subsets. Now, if you want to represent subset with a Venn diagram, remember I told you that subset means that one is a part of, or one is within the other. All right. So if I want to say that B is a subset of A, this is set A. Okay. In a Venn diagram, you represent the sets, sets by circles. So this is set A, the bigger one, and then set B is inside A, showing you that set B is a part of A, or set B is within A, or we say B is a subset of A. So this is the sign for subsets. All right, a curved C like this. This is a sign for subsets. Okay, a curved C. So this means B is a subset of A. B is a subset of A. So that's actually very quite straightforward. Then next we have union. Union of two sets. Now, a union is a combination, right? A union is a joining. A union means bringing things together. So if I say a union of a man and a woman, it means I bring a man, I bring a woman, I join them together. So it's the same concept that applies here. A union, the union of two sets, set A and set B, the union of set A and set B, we write it as this, a capital U, okay? U, that's union. The union of set A and set B means the combination of all the elements that are in A and B. Alright, so if I bring all the elements in set A, bring all the elements in set B, I put them together without repetition. Very important. You can't repeat elements. Alright, but if I bring out all the elements in set A and all the elements in set B and I put them together, what I'm going to get is the union of A and B. So all the elements in A or B or both, that's a combination of everything in them. This means the combination of all the elements in set A and B without repetition. Very important. So you don't write one element 2 times. So for instance, if we have that set P has the elements A, B, C, D, and set Q has the elements J, B, H, F, E. These are 2 sets. And they ask you what is the union of set P and Q. What they're just asking you to do is merge them, bring them together, join them. Alright? So all you just need to do is take all the elements in P and Q, but be careful that you don't repeat anyone. So we have A, B, the B appears twice. But remember I said no repetition, so we just pick one. Then we have C, we have D, we have E, we have F, we have H, and we have J. So this is P union Q. This is the set formed by the union of P and Q, taking everything in P and combining with everything in Q. If you represent it in a Venn diagram, this is your set A, this is your set B. Now, the union of both sets means everything in them. So the shaded part indicates A union B. Everything in A and everything in B. Alright, so that's union. There must be a place where they join, and then everything in A and everything in B. So this is how you write it: A union B. I told you the symbol for union is capital U, just a big U. Alright, A union B. So I hope that's clear. Everything in A and everything in B, bringing them together gives you a union. And then third, we have intersection. Okay, intersection. Now, intersection means where two things meet. Most of these are just English terms. So if you understand the meaning from English, you can appropriate it to sets. Intersection means where two things meet. An intersection of two roads means where two roads meet, which we usually call a junction, right? So intersection is where two things meet. So the same way, the intersection of two sets, let's say set A and set B, refers to all the elements that are common to both A and B. All the elements that are common to both A and B. So when we're talking about the intersection of set A and set B, we're asking what elements are common to A and B. What elements are in A which are also in B. So this means the elements in A which are also in B. That's intersection. Just the common elements that you find in A and also find in B. So the symbol for intersection is this N, small letter N. Alright, small letter N. So if we have this example that J is C, the elements in set J, you have C, D, B, A, H. And the elements in set K, you have A, B, P, Q, R. And then you're asked to find the intersection between these two sets. You're just looking for what is common between the two of them. What is in J that is also in K. And you can see that that is just A and B. There's A in J, there's A in K. There's B in J, there's B in K. So the intersection of these two is AB. That's all. AB. Okay, this is a sign for intersection, like I told you. Okay, so if we are using a Venn diagram to represent this, this is set A, this is set B. The intersection means where the two meet. So what is common to both A and B? Where do A and B overlap? That is the intersection. And that is this shaded part here. Okay, so that is the intersection of A and B. So we write it this way: A intersection B. Okay, and then finally we have complement. Complement. Now, complement here is different from, in English language we have two types of complement. We have this spelled with an E here, okay, and we have the one spelled with an I. The one spelled with an I in English means to give someone a favorable remark, to compliment somebody, all right, or to assist somebody properly or very well. But this compliment means, in this context of set, everything that is not part of the set under consideration. All right, so if I say the complement of a set A, I will write it like this: A is like saying A raised to power 1. So I write A 1 or A prime, if you want to call it that. Or some people also use A complement, that's raised to power C. Okay, now this refers to all the elements which are in the universal set but not in set A. Now you ask, what is the universal set? Universal set is just the total set for the question you're considering. That's the overall set, the umbrella set for that question or that situation that is under consideration. That's what we call a universal set. So the umbrella or overall set for the question or the situation in view. So for instance, if I'm looking at states in Nigeria, okay, our universal set for that particular question is going to be a set that contains all the 36 states in Nigeria, because we have 36 states plus the FCT. So the universal set in that question will be, okay, 37 elements containing all the states and Abuja. So a universal set is the umbrella set, the total or whole set covering all the possible elements of that question that you are considering. All right. Now, in that universal set, they now bring out another set and complement it. What they're asking you to do is bring out the elements that are in the universal set but are not in that particular set. So everything outside the set in question, everything outside set A in this case. So what is in the universal set that you can't find in A? So for instance, if your universal set is 1, 2, 3, 4, 5, that's the total set for this question you are given. You have elements 1, 2, 3, 4, 5. That's the if it's in economics, you say that's your population, right? That's your population, the total set, the total number, your overall how do I put it? Your overall playing field. Okay? Then you are given that set A is 1 and 2, element has elements 1 and 2, set B has elements 2 and 3 in it. Okay, now if we are still using economics terms, set E is your population, set A and set B are your sample or sample space. You know that the sample is a part of the population under consideration, right? I don't know if you did economics. The sample is just that part of the population, the part of the entire population that you're considering or you're studying at that point. That's the sample. So your universal set is the total or the umbrella set here. But you're now given two sets out of this. Set A, which is 1 and 2. Set B, which is 2 and 3. Now, if you're asked to find A complement, that means what is in the universal set that is not in set A? Or what are all the elements outside set A, all the elements beyond the reach or the purview of set A. And in this case, if set A is 1, 2, and we are considering this universal set, that means A complement will be everything outside A, which will be 3, 4, and 5. So if you remove set A, what is left? You can think of it like that. Then B complement as well. B is 2 and 3. So B complement everything outside B. Remove B, what is left? And if you remove B from your universal set, you remove 2 and 3, you're left with 1, 4, 5. 1, 4, 5. That's B complement, everything outside B. Alright, now if you represent this in a Venn diagram, if you want to represent A complement, this is set A, this first circle. The second circle is set B. Now A complement, remember I said, is everything in your this. For set, the rectangle represents the universal set. Like I said, your total or your umbrella set. So this is like your whole playing field, the entire box where all the elements are. Alright, so A complement means everything outside A. So you can see that everything else is shaded apart from A. That is A complement. Everything else is shaded. Everything outside A is shaded. Alright, so I'll take one example that will just help clarify all this. I believe it's already clear like this, but I want to take one example that has all these things, where you'll be asked to find intersection, complement, union, and then you see it play out. We have an example here. Let's see how we tackle this. Like I said, this is quite simple. Our question says E is the set of numbers from 1 to 20. So E is our universal set, and E contains all the numbers from 1 to 20. So we have 1, 2, 3, 4. Because of space, I'll just do 17, 18, 19, 20. Alright. So this dot 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 means that there are numbers missing. Alright. This dot 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 means that there are numbers missing in between. So from 5 to 16 are assumed to be here. And we did this because of space. But E means all the numbers from 1 to 20. And let's say A, B, and C are subsets of E, such that A is a set that contains the multiples of 5. So let's bring out the set of A. Multiples of 5. Now, I hope you remember your primary school mathematics. Multiples means the numbers that a particular number can divide without remainders. Alright, so example, multiples of 2, you have 2, 4, 6, 8, 10. In fact, all even numbers. Alright, so numbers that 5 can divide without the remainder between 1 and 20. And those numbers are 5, 10, 15, 20. Alright, so these are the elements of set A. For set B, the set B contains multiples of 4. So all the numbers that 4 can divide without the remainder between 1 and 20. So that's 4, 8, 12, 16, and 20. And then finally, C contains elements that are multiples of 3. All the numbers that 3 can divide without a remainder between 1 and 20. So we have 3, 6, 9, 12, 15, 18. Alright, so we brought out our set. Now we're asked to find, we have 4 things we're asked to find. So let's start. Number 1, A intersection B. Now, like I already told you, intersection means what is common to A and B. What is in A that is also in B. And if you look at A, we have 5, 10, 15, 20. If you look at B, we have 4, 8, 12, 16, 20. So the only thing common to these two, A and B, is 20. So this set, A intersection B, we only have one element. Alright, so if you remember, I mentioned something in our previous video. A set that has only one element is called what? A set which has one element, what do we call it? I want you to pause this video, put the answer in the comments, and then play the video and know if you got the answer right. Alright, so pause this video, there's no point cheating. Think if you can remember, what do we call a set that has just one element? Right? If it has no element, it's an empty set or a null set. What do we call it when it has one element? So I'll reveal the answer at the end of the video. Let me know if you got it. So just put the answer in the comments. Now let's continue. Let me put it here so I don't forget. One element. Okay, so at the end of when I'm done with this question, I'll put it. But try it now. Put it in the comments now, and don't search for it on Google. Try and remember what I told you. Alright. Now the second question here is B union C. So we're looking for the elements of B union C. Now I told you the union means everything in B and everything in C. That combination of everything in B and C. So this is going to be a long one. We'll start with 2. We're just going to write everything here together with everything here. So let's just write it, rearrange it. We have 3. Okay, let me write it from this side so that you can see. 3, 4. What's the next one? 6. Remember, B and C. 3, 4, 6, 8. Okay, you'll be taking it like that. So 3, 4, 6, 8, 9, 12. Down without repetition. So we are not taking it to 12, just one. Then 15, 16, 18, 20. So 3, 4, 6, 8, 9, then we take 1, 12, then we have 15, 16, 18, 20. Alright, so this is B union C. 3, 4, 6, 8, 9, 12. Just take one of the 12 without repetition, please. Then 15, 16, 18, 20. So this is B union C. Alright, hope that's clear. Then the third one we are asked to find is A intersection C. So now you ask yourself, are there intersection means common elements? So is there any common element between A and C? A has the elements 5, 10, 15, 20. C has the elements 3, 6, 9, 12, 15, and 18. So we have a common element. We have 15 here and 15 here. So again, this set has only one element. Okay, so I'll just repeat the answer here. Okay. Alright, so a set with one element is called a unit set. Unit set. Or a singleton. I hope you still recall. Okay, I hope so you got it right. So if you got it right, just give yourself a thumbs up in the comments. Okay, a set with one element is a unit set or a singleton. Alright, so this is a unit set, this is a unit set. And then finally, we have to find B intersection C complement. Alright, now before we can find B intersection C complement, we need to know what is C complement. So we have to first find the set of C complement. And I told you that complement means everything in the universal set that is not in C. So everything outside C with regards to the universal set. So let me stay this way. Now, our universal set is from 1 to 20. So if we remove everything in C, if we remove between 1 and 20, 1 to 20, if we remove 3, 6, 9, 12, 15, and 18, which are elements of C, what are we going to be left with? Alright, so I know we'll be left with 1, 2. Now 3 is the element of C, so we are removing 3. We have 4, we have 5, we are removing 6, we have 7, we have 8, we remove 9, we have 10, we have 11, we remove 12, we have 13, we have 14, we remove 15, we have 16, 17. If we remove 18, we are left with 19, 20. So these are the sets in C complement. Okay, this is the set in C complement. Everything that is outside C with regards to the universal set. So if I now want to look for B intersection C complement, so what is common between set B and the universal and C complement? What is in B that is also here? If I look at B, I have 4, 8, 12, 16, 20. There's 4 in B, there's 4 here. So 4 is common to both of them. There's 8 in B, there's 8 here. So 8 is common as well. There's 12 in B, but there's no 12 here. So 12 is not part of this. 12 is not common to B and C complement. There's 16 in B, there's 16 here. So I put down 16. And there is 20 in B and there's 20 here, so I put it down. Okay, so this is my answer for B intersection C complement. All right, so take note that first I had to look for C complement, so I removed all the elements of C from the universal set, and this is what I'm left with. Then I found the common terms between B and C complement. So what is in B that is also in C complement. Alright, so I said this is quite easy, and you can see that there's nothing difficult here. So this is your assignment. I want you to try this. Some of you have been doing well. You do the assignments and you submit for me to check, and I appreciate that. It shows you're putting in effort. So try this as well. Try it, solve it. You can send it to me directly on WhatsApp. Okay, my link is in the channel description, or you drop it on our Telegram community, so that even if I don't respond, other people in the community can respond to it. Alright, so the link for both my WhatsApp and the Telegram community are in this channel description. So do it and submit it there. You are told that E, the universal set, are all the numbers from 1 to 10. Alright, 1 to 10. So, and you're given that G is this and H is this. G contains this element and set H contains this element. So find G union H prime, or G union H complement. That's the first thing you have to find. Then find G intersection H, and then show that this is equals to this. So you're going to find what are the elements of G intersection H complement. Okay, and then you tell us if it is equal to the elements in G complement union H complement. So we are going to do this separately. Find the elements in G intersection H complement. You've already done G intersection H here, so just complement it. Remove all the elements here from the universal set. You get this. Then for this one, you have to find what is G complement. So you remove all this from the universal set. And then H complement, you remove all these from the universal set. Then G complement, H complement, you combine them, that's their union. Then the final answer you get on this side, is it equal to what you got here? If it's equal, then you tell us they are equal. If they are not equal, you tell us they are not equal. I hope you remember the sign for inequality. This is the sign. So if two things are not equal, you use a crossed out equality sign. Alright, so thank you so much. We'll end here for today. I hope you've learned something beneficial, and I hope set is becoming simpler to you. Now in the next videos, we'll look at Venn diagram problems, because I know that's what many people think of when they think of sets, but there are things that come before Venn diagrams, and if you understand these, Venn diagrams are quite simple once you know this. So the next videos will look at two Venn diagram problems, two sets Venn diagram problems, and 3 sets Venn diagram problems. So I'll see you soon. Please don't forget to subscribe if you're new. Ring the notifications bell as well, so you don't miss our videos. And if you found this helpful, like this video so that YouTube can recommend it to more people. Drop a comment as well, very important. Let me know what you think. Let me know if you have questions, and then share the video widely, okay, on your status, on Facebook, with your friends, in your groups. Put it out there everywhere. All right, God bless you. I'll see you soon again with another video on set. Till then, keep learning, keep studying, and you get